This video is going to talk about composition of functions. Before we can talk about composition, though, we have to remember just basic function evaluation. So let's look at two functions. Let's say we have the function f of x, and f of x equals x plus 7. And let's take g of x, and g of x equals 3x minus 2. So just to remember what function evaluation is, let's use these two. Let's find f of 6. Now, remember, this means that we are replacing the x in the f function with a 6. So that means we're going to end up with 6 plus 7. We do our basic evaluation and we say that f of 6 equals 13. Let's use the g function now. So let's have g of negative 2. So in this case, what we're doing is we're replacing the x with a negative 2. So wherever you see an x in the g function, you want to replace it with a negative 2. So we have 3x minus 2, and we're replacing it with that negative 2. Now it's just a matter of doing some calculations. We get negative 6 minus 2. So g of negative 2 equals negative 8. Remember, you can also go backwards. So we could say, oh, we know that f of x is equal to 1. This means that you're going to replace the whole thing, f of x, with a 1. So what you're going to end up with is 1 equals x plus 7. See how we replaced where f of x it was with the 1 because f of x equals 1. Now it's just a matter of isolating x and solving. So I'm going to subtract 7, and we'll say that x equals negative 6. We can also use more than one function at a time. So remember that, let's say we had g of 3 minus 2 times f of 0. So here's what this means. It means using the g function, you're going to replace the x's with a 3. And then for the other statement, we're going to replace the x in f with a 0. So what you're going to end up with is 3 times 3 minus 2. And then we're also going to evaluate something else. So we're going to minus 2 times whatever that would be is 0 plus 7. So now we'll do our evaluations. We're going to get 3 times 3, which is 9, minus 2, which is 7. So that's g of 3. And let's look at the f function now. We have minus 2 times 0 plus 7, which is 7. So we're going to end up with 7 minus 14. So g of 3 is 7, and 2 times f of 0 is 14. So g of 3 minus 2 times f of 0 is 7 minus 14, which yields us negative 7. So you can see that we have already done a lot of the basics we need to do compositions of functions, except this time, instead of doing everything individually, we are going to use them both in sequence. Since we're already familiar with f and g, I'm going to use those same two functions. F of x is x plus 7, and g of x is 3x minus 2. Now, a composition of functions is going to be written something like this. So what this statement actually is, if you wanted to say it in words, you would say f of g of x. You might also see another notation, so I just want to point that out. You might also see it written as f with a little dot, open circle, g of x. They mean the exact same thing. So if you see either one of those two things, it's just asking you to find f of g of x, or f composed of g of x. Now, a lot of the times what we do is we think about this as inside out. What we need to do is look at the inside, evaluate that, and then go to the outside. So an example of where you're going to see that is, let's say we were going to find f of g of 2. So basically what this means is that you are going to find g of 2, whatever that is, it is going to be put into the function of f. So we're going to have to do two calculations. We're going to start with g of 2. So g of 2 is going to be 3 times 2 minus 2, which is 6 minus 2, which is 4. So now we know what goes inside our function. So our new function is f of 4, because g of 2 is 4. Now we can go up to our f function and go, okay, well we know how to do this. That means 4 plus 7, which is 11. So f of g of 2 equals 11. So really, it's not anything new. You're just applying those things in sequence as opposed to doing them individually in isolated cases like we did last year. Let's use our two functions one more time. Let's try another one. Let's do let's mix it up a little bit. Let's do g of f of 0. So now remember, we're going to work inside out. So the first thing we're going to do is f of 0. We're going to find that number and then replace that in the g function. So f of 0 is going to be 0 plus 7, which is 7. So now our task becomes finding g of 7. So again, just go up to your g function, okay, replace all the x's with 7, and you get 3 times 7 minus 2, which is 21 minus 2, which is 19. So we can say that g of f of 0 equals 19. Decided to mix things up on you guys a little bit. We're going to move on to another pair of functions. We're going to have the function h and the function g. We're still going to use them to do some compositions. So let's start out with h of g of negative 2. Now remember, you're going to work inside out. The first thing you need to do is find g of negative 2. So we're going to use our g function. G of negative 2 is going to be 3 times negative 2 plus 2, which is negative 6 plus 2, which is negative 4. Now our task becomes finding h of negative 4. And again, you replace every single x with that value. So when we look at the h function, it's a little bit different. We have more than one x, but that's okay. You just take out those x's, and every time you saw an x, you're going to replace it with a negative 4. And again, it just becomes some simple calculations. Negative 4 squared is going to yield us 16, then minus 8 minus 5, which is going to be 8 minus 5, which is going to be 3. So we can say that h of g of negative 2 equals 3. So let's look at it. Let's look at g of h of 4. So here, the inside function is h. So we have to find h of 4 first. So h of 4 is going to be 4 squared plus 2 times 4 minus 5, which is 16 plus 8 minus 5, which is 24 minus 5, which is 19. So now we go over to our g function. All we've done is found the inside. We have to actually go and find the outside too. G of 19. Again, you're just going to replace all the x's with the 19. In this case, there's only one x to replace. So we're going to start out by doing 3 times 19. So that's going to get us 57 plus 2, and that's 59. One thing a lot of people do is they forget about that plus 2. So you want to make sure you remember that and do the whole evaluation. So g of h of 4 equals 59. Now on the first slide I talked about going backwards, and we can go backwards with these as well. I'm going to move to a clean page, and we'll go backwards with these same two functions. So still using the functions h and g, now we're going to go backwards. And what that would look like for a composition would be, let's say, g of h of x equals 11. Now this is a little bit trickier than just simple composition evaluation because you need to think about it opposite. We're going to be thinking, instead of inside out, we're going to go outside in. Here's why. Because you know that g of some number equals 11. So what we have to do is find out what that some number is before we can find out what h of x equals. So g of some number, some unknown, is going to equal 11. So you take your g of x and you set it equal to 11. That's going to look like 11 equals 3x plus 2. Then we need to solve. So we'll subtract our 2, get 9, 3x, divide by 3. And so you know that x equals 3. Here's what this tells you. It tells you that that something, that missing something, is 3. But remember, g of h of x equals 11. So we know the missing part, that 3, is the same as h of x. So now we have to go backwards with h of x, because we know that h of x is the same as 3. That's what would get us that 11. So now you have to use your h function. And this is where things get fun, because h is a quadratic. So we can set that equal. We get 3 equals x squared plus 2x minus 5. We can't solve this one as simply because it's quadratic. And remember, for a quadratic, we want to get it equal to 0. So to get this set up, I'm going to subtract 3 from both sides. So we get 0 equals x squared plus 2x minus 8. And then we get to do my most favorite thing in the whole wide world, which is factor, because that's how we solve a quadratic. So in this case, we're going to be thinking of things that multiply to be negative 8 and add up to be 2. In this case, it's going to be x plus 4 and x minus 2. We're not quite done yet. We still haven't actually solved anything yet, because we just have our factors. So remember, when you factor, you set each factor equal to 0, and that's going to get you your solutions. So in this case, our solutions are going to be x equals negative 4 and x equals 2. So all of that work, all of that going backwards, got us to find x. So we knew that g of h of x, I'm going to rewrite that down so you think about it. G of h of x equals 11. And we had to go backwards to find out what x equaled. We wanted to solve this thing. When we did, we found out that x equals negative 4 and x equals 2. And if you took these things and you put them back into the h function and then back into the g function, you would end up with 11 both times. Going backwards is kind of crazy, so let's try another one. Again, I'm going to move to something a little cleaner. So still using our h function and our g function, we're going to do one more going backwards problem so you can see another example of that. Let's find h of g of x when that equals negative 6. So recall what we talked about. H of some unknown is equal to negative 6. We want to find that unknown. We want to find out what goes in there, because that's going to help us find g. So now we're going to start with the h function. So we know that h of x equals negative 6, which means that negative 6 equals x squared plus 2x minus 5. Now this is a quadratic, so we need it to equal 0. I'm going to add 6 to both sides. We're going to get 0 equals x squared plus 2x plus 1. Now, again, yay, factoring. We get to factor this thing and actually find those missing values. So what multiplies to be 1 and adds to be 2? That would be positive 1 and positive 1. When we solve our two factors, we're going to end up with x equals negative 1 and x equals negative 1, which is kind of handy because now we only have one thing that we need to think about. They're the exact same answer, so either way, if I plugged in negative 1 to the other function and I plugged in negative 1 to the other function, I'm going to get the same thing. So I just need to do one task. That was really nice of me to set that up this way. Alright, so let's think about where we're at. We know this unknown value now. We know that that is equal to -1. But we also know that that unknown is g of x. So we are at a point where we know that g of x equals -1. Now what we need to do is go back up to the g function, and we're going to replace g of x with -1. So we get -1 equals 3x plus 2. And now this is not a quadratic, so this is just a matter of undoing, getting x by itself. So that would be subtracting 2 from both sides. So you get -3 equals 3x. Divide both sides by 3. You get x equals -1, which was way too convenient, but there we have it. We now know that when h of g of x equals -6, that x equals -1. I'm going to give you guys a break. We're going to go back to some linear functions and not worry about those quadratics anymore. We're going to do another couple of practices. Just in case you forgot, remember we don't always go backwards. We might be asked to find something like this, f of g of -2. Now we know the inside, we know x, and we want to go backwards. We want to find what that equals. So we're going to go out. We're going to go inside out. We're going to start with g of -2. That one's easy. We just plug in a -2 into the g function wherever we see x. Then you just do some evaluation. Okay, that's -6 minus 2, which is -8. So now we are at the point where we know that g of -2 is -8. So we are actually finding f of -8. Again, replace your x's. You get -8 plus 7, which equals -1. So what we know at this point is we know that f of g of -2, f composed of g of -2, is equal to -1. Now let's go backwards again, just for kicks and giggles. Come on. All right, let's find g of f of x when it equals 10. So this time we don't know x. Our task is to find x. So we need to work our way backwards. We know that g, composed of some number, is equal to 10. So we use our g function first. We go, okay, well g of x equals 3x minus 2. So 10 equals 3x minus 2. Since this is linear, we can go ahead and solve it regularly. Add 2 to both sides. Let's get 12 equals 3x. Divide both sides by 3. You get x equals 4. Now keep in mind, all we've done there is we've found that missing value. We found that g of something is going to equal 10. But that doesn't actually help us find x, because we know that that something, that 4, is the same as what was inside, and what was inside is f of x. So we know that f of x equals 4. So we're going to replace it. We're going to go, okay, well 4 equals x plus 7, because we're replacing f of x. Since it's linear, we can just go ahead and solve. So we get x equals -3. And that means that when g of f of x equals 10, that means that x equals -3. And if you were to plug it back in, you would get that same solution. We can also do composition of functions when we have tables and graphs. Some people like this a little bit better. There's a lot less calculations involved, and it's just a matter of reading your graph or your table. So here we have 3 functions. The table has f and it has g, and then the graph is h. We're going to use this to do a couple of examples. So let's start out with g of h of 7. So this time we're basically doing an evaluation. We want to find that final value. So we know the inside. We know 7, and we're going to work our way out so that we can get the outside. So h of 7. That means that in the h function, we're going to where x is 7, and we're going to see, what does that equal? Well, there it is right there. It's negative 2. So that makes our problem become g of negative 2, because h of 7 is negative 2. So now you go up to your g function, you go, okay, well, x is negative 2. So we go in our table to where x is negative 2. We look at what that equals in g, and it's 9. Done. So we can say that g of h of 7 equals 9. Another one. Let's say we gotta use f because he's so sad. Let's find a f of g of 1. Again, we want to find what that equals, so we're working our way inside out. I wish you guys could see me right now because I'm making this thing with my hands going inside out. Looks like a hyperbola. G of 1. Let's start with the inside. G of 1. So you're going to go in your table. Okay, well, here's where x is 1. And what does g equal? It equals 3. So really, what we're trying to find here is f of 3. So now again, we're looking at our table, and we're going to go, okay, well, we know that x is 3. We want to find what the value of f is when x is 3. According to our table, it's 9. So g, or f of g of 1 is equal to 9. That worked out way too well. Okay? Let's see if I can get another 9. Let's try one more example. This time we're going to go backwards, because I like to go backwards. So for going backwards, we are going to find h of f of x equals 1. Uh-oh. This time we don't know x. We want to find the inside. So we have to start with the outside. So here's what we got to think about. We know that h of some unknown number is equal to 1. So that means h of x, if you want to think about it that way, equals 1. Or y equals 1. So when we're finding this unknown number, we're going to look on our graph at where y equals 1. We're going to look along and we're going to see where does it hit our graph. Looks like it happens right there at 6. So that lets me know that my unknown, my missing value, is 6. But we're not done because we know that h of f of x is 1. So we have to find out what x is. We don't know x yet. We only know f of x. We know that f of x equals 6. And again, think about it this way. Y equals 6 because we're going outside in. We're trying to find x. We don't know x. It's right there. Look, we don't know it. We want to find when y is 6. So f of x in our table, well, we go on our table and go, okay, where does that equal 6? Aha, there it does. And what is the value of x when that occurs? 0. So, from our final statement, we knew that h of f of x equaled 1, and that got us to the point, after working outside in, to the point where x equals 0. Now, just to show you that this really works, we can go backwards. We can actually evaluate, oh hey, what's h of f of 0? Let's see if we actually get 1. So if we go to our table where x is 0, we see that f of x is 6. So that means we're really finding h of 6. Now you go up to your graph and you go, okay, well, where is x6? Well, there it is. Ta-da! And it's 1. Isn't that cool how it works out? I love math. Math works. Now, compositions with numbers are all fine and good, but we don't always do compositions with numbers. In fact, you're going to do some fun stuff when you get to calculus, like chain rules and things like that. You're actually going to need to do compositions with variables in them. So we're going to do a couple of examples with variables. Let's say that we wanted to find f of g of a. Okay, well, that means that we know that x is the same as a. We can replace it. And so if we go to our g function and we go, okay, we're going to replace all of those x's with a's. We're going to end up with 3a plus 2. And that's it. That's all you can do. So when we actually do our evaluation, what we're actually finding is f of 3a plus 2, because that's what g of a equals. So it's really not that bad. You're going to use the exact same steps. Wherever you saw an x, in the f function, you're going to replace it, you're going to replace that x with 3a plus 2. And then it's just a matter of using your polynomial skills, combining like terms, distributing, and all that fun stuff. So that's going to get you 3a plus 2 plus 7, which is 3a plus 9. So we are able to say that f of g of a equals 3a plus 9. And that's it. Where you're going to want to do this a lot is when you just keep it as x, though. So we'll do an example where we keep it as x. So let's find g of f of x. This means that we are going to take this value, f of x, and we're going to input it into the g function. So g of x plus 7 is what we're actually going to find, because that's what f of x equals. So now in your g function, what you're going to do is you're going to write your g function, and wherever you see an x, take it out. You're replacing x with the whole f function, x plus 7. Now, again, you're not going to find a single number as your answer, but this is why we had to learn all those polynomial skills. This is at the point where you go, oh my gosh, I just need to distribute. And I get 3x plus 21, and then plus 2. Now it's just a matter of combining like terms. 3x plus 23. So we know that g of f of x equals 3x plus 23. It's like I taught you all that other stuff for a reason. So now you kind of have seen some different examples of compositions, and you want to remember a few things. So I'm going to do a recap slide like I've been doing on a lot of my recent videos. So to recap our compositions, we're going to remind you that you might see something like this, f, g of x. And what that really says is f of g of, x, or f composed of g of x. And when we want to do an evaluation, when we have something where we might have f of g of 6, this is where we work our way inside out. Because we know the inside, we know the x value, we want to work our way out. We know x, we want to find y, so we work our way out. Now you might see another type too, and that would be if we had g or f of g of x equals 3. Now we have to work our way outside in, because we are trying to find x, because we know y. There's y, yay, it's 3. We want to find x. We want to find that inside value. And again, you can do it with variables too, and sometimes you're just evaluating with variables, and that's just using some distribution and some combining like terms. The biggest thing we want to get out of these compositions, though, is making sure you know what you're trying to find. Do you know x or do you know y? And that tells you which technique to use.